Okay, hello everyone. We are going to design a circuit which will work as a 3-bit down counter. So down counter, which will work as a down counter, and it will be a synchronous circuit by using the T flip-flop. So what are the steps we need to follow to design 3-bit down counter? So here, first we will draw the state diagram. Second, we have to draw the state table. Third, we have to draw the K-map to find out the expressions of the input for the T flip-flop, and then we will draw the circuit diagram. So let's see the first step, that is the state diagram. As we are designing the down counter, it will counts in the downward direction from 7, 6, 5, 4, 3, 2, 1, 0, again 7, right? So how to draw the state diagram? It's simple like this only, but in the binary form. So that means 7 will be represented in the binary form as 7. Then the next state will be 1, 1, 0. Next state will be 1, 0, 1. That means 7, 6, 5, then 4, then 3, then 2, then 1, then 0, and then 1, 1, 1. So this is the complete state diagram. And by using this state diagram, we have to draw the state table. OK, so here in the state table, there are some parameters that are required. First one is the present state. Next is next state. First, we will write down these present and next state, and then we will find out what will be the value for this T flip-flop if you are using the T flip-flop for the designing. So as this is the 3-bit down counter, we will write down QC, QB, and QA are my 3 bits at the present state. And as we are using 3 bits, how many possible combinations will be there? Total 8 possible combinations: 0, 0, 0, 0, 1, 1, 1, 1. Similarly here, I'm just writing all the possible combination if you have the 3 bits at the input. So it will be like this. Now we have to find out the next state. So next state will be represented as QC plus 1, QB plus 1, and QA plus 1. Just to represent, these are the next state. Now if you see, if you are in state 0, 0, 0, if you are in state 0, 0, 0, next state will be 1, 1, 1. By using the state diagram only, we have to find out the next state. Here, if you are in the state 0, 0, 1, if you are in state 0, 0, 1, what will be the next state? It will be 0, 0, 0, right? So that means you have to use the state diagram to find out the next state. If you are in a state 0, 1, 0, then you see next state will be 0, 0, 1, right? So here you can use the state diagram to write down the next state. So this is 0, 1. Now if you see, if you are in state 1, next state is 0. If you are in state 2, then state is 1. Similarly, 3, 0, 1, 1 is 3. So next state will be 2, 0, 1, 0. If you are in present state is 4, 1, 0, 0 is 4, then the next state will be 0, 1, 1. If you're in state 5, then next state will be 1, 0, 0, because it's a down counter. If you're in state 1, 1, 0, then next state will be 1, 0, 1. Similarly, if you're in state 1, 1, 1, then next state will be 1, 1, 0. Clear? So we have calculated the present state and next state. Now we will use the T flip-flop for this designing. So here we require the excitation table of T flip-flop. So excitation table of So here we will consider Qn plus 1, and this is the value of T, 0, 0, 1, 1, 0, 1, 0, 1. So what will be the value of excitation table T is what? 0, 1, 1, 0. To understand it better, if you see if they are same, then its value is 0. If it's different, then its value is 1. The same concept you have to use it here also. to find out the value of TC, TB, and TA. That means here you have to consider the value of QC with QC plus 1 and find out the value of TC. So here if you see this is 0, this is 1. Now you match with the excitation table. If it is different, that means 0, 1, output will be 1, right? So here I am writing as 1. Now you see this is 0, this is 0. So it will be 0 because as you know, if they are same, then it will be 0. Here also same, so 0. Here also is same, so 0. Here is different than 1. Here it's same, so 0. Here also is same, so 0. Here also is same, so 0. Understand? Similarly, to find out the value of TB, you have to compare QB and QB plus 1. 0, 1. So it's different. 1, 0, 0. Same. 0, 1, 0 is different. So 1. Similarly, 1, 0. So same. 0, 0, 1. Different. 1, 0, 0, 0. 1, 0 is different. So 1, 1, 1 is same. So 0. Clear? Same thing you have to do with for the TA to by comparing the value of QA and QA plus 1. 0, 1 is different. So 1, 1, 0 is different. So 1, 0, 1 is different. 1, 1, 0 is different. So 1, 0, 1 is different. So 1, 1, 0 is different. So 1, 0, 1 is different. So 1, 1, 0 is different. So 1. Now my state table is completed and we have to find out the value of TC, TB, and TA to find out the expression for these values. So I'm using the K-map here for finding the value of TC. So if you see this state table, how many input variables are there? For us, we have 3 input variable QC, QB, and QA. That means you have to draw the 3 variable K-maps like this here. This is 0, this is 1, 0, 0, 0, 1, 1, 1, and 1, 0. The value for which your TC is equals to 1, that's value you have to fill it here in the K-map. So here you can see TC is 1 for 0, 0, 0. So wherever its value is 0, 0, 0, you fill it by 1. Similarly, here also it's 1 for the combination of 1, 0, 0. That means 4, 1, 0, 0. Here also it's 1. And rest all other values are 0. No need of to fill the value with 0. Now here in the K-map, you know that we have to make the combination. So here we can make a pair like this. As this is cancelling with 0, 1, the value of TC will be given by QB bar QA bar. Right? Now we have to find out the expression for TB. So TB will be calculated like this. Again, here in TB, we have 3 variables. So here 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Here I am taking QC and QB, QA as a inputs, right? These are the input variables. Now, here you see for TB is 1 for 0, 0, 0. So here at 0, 0, 0, you fill it by 1. Similarly here, it is 1 for this combination 0, 1, 0. So it's for 2 is 1. So this is 0, 1, 0. So here you will get 1. Similarly, for the rest of the values also, you check it here. So here is 1 again for 1, 0, 0 and 1, 1, 0 means 4 and 6 is 1. So this is 4 and this is 6. So it's 1. Now, as you know, in the K-map, you have to make the combinations. So here we can make a combination like this, and this QC will cancel out. Here, this QB is also cancelled out. Only QA bar will come. So the TV will be equals to QA bar. Similarly, we have to find out the value of TA. Again, here we have 3 variables. So we will make a 3 variable K map. Here I'm considering this is QC, this is QB, and this is QA. And it's following the gray code. That's why the number is like 0, 1, 3, and 2. After that, wherever your function value is 1, you fill it by 1. So here you see TA is 1. TA is 1 for all the condition, all the possible combinations. So here also in the K map, you fill it by 1. Now you see here we are making the octal combination and all are having the complemented form. So the TA becomes 1. Now we have all the expressions and we can draw the circuit diagram here. So now again, I am writing the expression that we got it from the K map. This is QB bar, QA bar. And similarly, we calculated TB is equals to QA bar and TA is calculated as 1. Now here I am making the T3 flip-flops because we use 3T flip-flop for the designing. So here this is the 3 bits. One T flip-flop here I am representing by A, TB and TC. Why? Because the last T flip-flop will be MSB always, and the first flip-flop will represent as LSB. TA value is 1, so here I am writing TA and I am giving 1 here. TB is given by the QA bar. So here you will get QA and here you will get QA bar. That QA bar you have to connect it here as a TB. Similarly, for the TC, we require one AND gate, and here you provide QB bar and QA bar. And that you have to provide as a TC. Now here you will get QB and here you will get QC. Along with that, you can also draw the complemented outputs like QC bar here, right? Now, as this is the synchronous circuit, you have to give the clock to all the flip-flops, same clock to all the flip-flops like this. And this is the complete circuit for 3-bit down counter synchronous using T flip-flop.